When you draw site plans, you represent the topography with contour lines. And contour lines are those squiggly lines. They represent lines of equal elevation. And I think looking at this model helps us visualize how those are equal elevation. Or if you look at a water reservoir where the water level is low, like this one, the water was all at the same level and it made lines of equal elevation, which are similar to contour lines. When you're reading a plan, you might call it a grading plan or a topo plan. Topo is short for topography. You look at the numbers on the contour lines in plan, and those represent the difference in elevation. So this plan at the top looks like this in section, and each one of those lines is a different height, a 2-foot difference in height. So this map has a 2-foot contour interval. This is part of a plan around Hendricks Park in Eugene. And the contour interval here, if you squint at it, you'll see the contour interval is 20 feet. So each line represents a difference in elevation of 20 feet. A big contour interval like that gives you less detail. You don't get much detail, but you can show it from a distance like this. Notice that every fifth line is thicker, and those every fifth lines are called index contours. The only reason they are there is just to help you get oriented and keep track of what number you're on. So in this map, we have a 20-foot contour interval, which means every fifth line is 100 feet apart. Here's a topo map of LCC. This is the LCC campus in here. You can see it has a 20-foot contour interval, so again, less detail. Here's a map around part of LCC with a 2-foot contour interval. The Lane Council of Governments commissioned this map. They were trying to figure out wetlands and hydric soil locations and water flow. So you can see how when the lines are close together with a small contour interval, you get a lot more detail. Every feature on the land is either a water gathering feature or a water shedding feature. And the water flows perpendicular to those contour lines everywhere, whether it's being gathered or shedded. Contour lines have certain patterns that you can learn to read, and those are called contour signatures. And if you read a lot of, or just some, topo maps, contour plans, you get so you can begin to visualize what these lines are representing as you're looking at them. So for example, concentric rings represent either a hill or a depression, and what you have to do is look at these numbers representing the elevation to determine whether that's a hill, which this one is, or a depression. There are a couple of hills. Another contour signature is that contour lines point up valleys. So here's the thing in plan view. You can see those V-shaped lines are pointing up a valley. And valleys are water gathering features. Contour lines point down ridges. Ridges are water shedding features. And a handy trick for visualizing whether you're looking at a valley or a ridge and whether it's pointing uphill or downslope is take your topo map, your plan, like let's look at this one here, and take the piece of paper, if it's on a piece of paper, and turn it so that you are looking downhill. So here on this one, we got a 9 at the top, then 8, 7, 6, 5. So looking downhill, we'd turn the paper so we were looking from the 9 towards the 5. Then tip the paper up like you're reading a book or a poster. So now here's this page tipped up. And the shape of the contour lines will represent the profile of the thing you're looking at. In this case, we started at the 9, we're looking towards the 5, we tip the page up, and this looks like a bump. It looks like a ridge. So we are looking at a contour signature for a ridge. If we did this other one over here, we'd have to rotate our paper 180 degrees in order to be looking downhill, and then when we tipped it up, we would be looking at a V-shaped valley. Here's this topo map around LCC again. There's LCC. And looking at these squiggly contour lines, you can see there's a ridge. There are the contours pointing downhill. This is that Coriel Ridge across Bloomberg that you see from the campus. And here are some lines pointing up a valley. So there are some hills up here, and there's a kind of a depression in there. Then, if you see lines that are fairly equally spaced, you have a uniform slope, and often that indicates a man-made, a human-made slope, because natural slopes are not that regular. If the lines are closer together, it's a steeper slope. So here they're closer together on a convex slope. Here they're closer together on a concave slope. Basic idea is when they're far apart, it's a gentle slope. When they're close together, it's a steep slope. Here is a map of the area around Mount St. Helens, the volcano in Washington State from 1980. Here is a closer view. This is a U.S. Geological Survey topo map of Mount St. Helens from 1980. So these were the contour lines before the volcano erupted, and you can see they get steeper near the peak. Here is a close-up of the topo map after St. Helens erupted. And so here you can see all the contour lines, and inside the crater, see how close together those are? Every 5 lines is an index line, and those index lines are just stacked up on top of each other. So this is very, very steep in here. In the floor of the volcano, in the crater, see how far apart those lines are? That is very flat in there. And then there's a concentric ring representing the lava dome. Contour lines always close somewhere. It might not be on your map or your plan, but somewhere on the planet they will close. And they always occur in pairs, because every feature is a water shedding or a water gathering feature, so we always have pairs on either side of something, although it might be off your map again. Contour lines, naturally occurring contour lines, cannot split. So if you see a situation like this on a contour map, you know something has gone horribly wrong with this map. Something needs to be fixed. The one time contour lines can split is if you have a contour going around a building foundation, and for some reason you're showing the contour elevation on the structure as well. I don't know why you would, but you could. And finally, last 2 slides, contour lines cannot cross. The only time contour lines can cross each other is if you are looking at an overhang, like a cliff where the top of the cliff sticks out farther than the bottom of the cliff. Or like this frightening image from the early 20th century, there would be contour lines crossing. So now we'll go on to talk about grading plans in the next slide, next lecture. But something to notice at the beginning is in a grading plan, we use dashed contour lines to represent the existing topography, and then we will draw continuous lines to represent the new topography that we want to have excavated. So more on that later.